In this course, we will see in detail the different processes to help a network. On this topology, the PC cannot communicate with the server that is on a remote network. We will see 4 stages of troubleshooting, which are recommended to do from the PC. First of all, we start by trying to pin the loopback address. To do this, you have to open a command prompt window and do a ping of the IP 127.0.0.1. This IP is the loopback address. It allows you to test the TCP protocol of your own machine. If the ping succeeds, it's because the TCP IP battery works. And if it fails, there is a TCP IP failure. And in the latter case, it should be able to reinstall or reset the PC network card. Then we can try to pin the local host, that is, its own IP. In the example, this is the PC IP, which is the 192.168.1.1. If the ping is successful, it's because the PC's network card works perfectly. The TCP IP battery can communicate with the network card through its driver. If the ping fails, the PC's TCP IP settings should probably be reviewed in detail. If the problem has still not been targeted, we can test a ping to the default gateway. In principle, this is the IP of the router's interface. On this topology, it is the IP 192.168.1.254. If the ping works, it means that the network card is well connected to the switch and that it can communicate correctly with its own local network. And if the ping fails, it's because there's a local problem that could be anywhere between the PC and the router. If the first 3 steps succeed, while there is still a communication problem between the PC and the server, we can test a ping of it directly. That is, from the PC, we launch a ping 192.168.2.1. In this example, we see that the ping works perfectly. That means that IP communication between the PC and the remote server is good. The remote physical network is functioning. If all these steps are correct, and there is always a communication problem with the server, it is because there is probably a problem of name resolution, in which case you should think about checking the DNS settings. The main objective of a network admin is to ensure that network equipment is operating properly. We will see the main commands that we need to know to help the network. The ping command tests the accessibility of another machine through an IP network. It also measures the time it took to receive the response, which is called the RTT, the round trip time. This command uses an ICMP request query and awaits an ICMP reply response. Repeated mailing provides statistics to determine the rate of lost packages and the average response time. The traceroute command, or TRACET on Windows, is a command that tracks the paths an IP package will take to get from one point to another. IP packages are routed to the destination from one router to another. Each router examines its routing table to determine the next router. The traceroute command will identify the routers that have been crossed and indicate the time between each router, as well as possible packet losses. This information is very useful for diagnosing routing problems, such as loops, that is, IP packets that go in circles. The command ARP-A shows the match between IP addresses and MAC addresses on a PC. The showIP-ARP command is identical to an ARP-A, except that it runs on a Cisco router, and also displays the ARP table. ipconfig, or ipconfig/all, is a command line utility available on all versions of Windows. It allows you to get the IP settings of a PC. The all option at the end of the ipconfig command displays the IP address network mask, and gateway by default for all physical and virtual network cards. It even displays DNS settings. The telnet command is an application that connects to remote devices. Telnet and even SSH are virtual terminal protocols that are part of the TCP/IP suite. They allow you to connect from a network device to one or more remote devices. To connect to a host that supports telnet, you need to use the telnet command, plus the host's IP to connect. And SSH is the replacement for telnet, which is much more secure because the communication between the client and the server is encrypted. There are two versions of SSH, SSH v1 and SSH v2. The best is to use SSH v2 because it uses a much more improved encryption algorithm. To start an encrypted session with a remote network device, you must use the SSH command plus the host's IP to connect.